Section 10.2 looks at trigonometric functions of angles. The circle definitions for trigonometric functions says let theta be an angle in standard position. As a reminder, an angle in standard position has the initial side on our positive x-axis, and it rotates about the vertex, which is at the origin, to some location somewhere, and it ends at our terminal side. And it says let xy be the point where the terminal side of that angle intersects the circle x squared plus y squared equals r squared. We're going to say this is our point P, and it has an ordered pair xy. And our angle theta rotated. The distance from the point to the origin is r. So this distance here is r. And r is equal to the square root of x squared plus y squared. We simply took the square root of both sides of that circle equation. And the 6 trigonometric functions of theta are defined as follows. You should be familiar with sine, cosine, and tangent from geometry and algebra 2. We're going to add in cosecant, secant, and cotangent in this chapter. Remember, you're always going to think of the triangle that is created here by our point, and it's always going to be a right triangle where the distance here is x and the distance here is y. And our r is always going to be positive. R is always greater than 0. R will never be less than 0. So if we want to find sine, the sine of this angle is going to be the y value or the y coordinate, which is this distance here, divided by the radius or r. Cosine is the x distance or the x value divided by r, and so on. Our new topics that we're looking at here are cosecant, which is simply the reciprocal of sine. Notice that sine is y over r. Cosecant is r over y. Then we have secant, which is r over x. And that is related to cosine. So remember, S and C are always going to be related. C never goes with C. Cosine and cosecant are not related. Cosine and secant are. And then the last one is cotangent. And tangent is y over x. Cotangent is x over y, or the reciprocal of tangent. Example number 1 here says, the terminal side of an angle theta in standard position passes through the point 815. Find the values of the 6 trigonometric functions of angle theta. It's going to help us to draw a picture so that we can visually see what is taking place. So this tells us that we have a point 815. So our point 815 is going to be out here. And this angle started on the positive x-axis, and it rotated through to get to that point, 815. We can then, from there, create a triangle. We bring this down. We have a height here of 15. And we have a horizontal distance of 8. And here is our angle theta. We rotate it in this direction. We know our x. Our x is 8. We know our y is 15. All we need now is to know what r is. And we know that x squared plus y squared is equal to r, or we could say r is equal to the square root of x squared plus y squared. We have r equals the square root of x squared plus y squared. So here r is going to be the square root of 8 squared plus 15 squared, which gives us the square root of 289, and the square root of 289 is 17. And this equation comes from the fact that we have a right triangle created here, our x side and our y side. And the way that we find the hypotenuse in a right triangle is x squared plus y squared equals r squared. Now we have all of our values. We have that x is equal to 8, y is equal to 15, and r is equal to 17. We can then evaluate each of our trig functions. In this case, sine of theta is going to be y over r. Y is 15, r is 17. Cosine of theta is x over r. X is 8, r is 17. Tangent of theta is y over x. Y is 15 and x is 8. Then we need to find cosecant. Cosecant of theta is r over y, which is 17 over 15. Secant of theta is r over x, or 17 over 8. And cotangent of theta is x over y, 8 over 15. Or since you're very familiar with sine, cosine, and tangent, you could simply take the reciprocal or flip sine to get cosecant, flip cosine to get secant, and flip tangent to get cotangent. So you don't necessarily need to memorize secant, cosecant, and cotangent. Just remember that relationship. Part B, the terminal side of an angle theta in standard position passes through the point -3, -4. Find the values of the 6 trigonometric functions of angle theta. We're passing through the point -3, -4, we have the point down here at -3, -4. Our angle started on our positive x-axis, and it rotated around and ends down here. And we can then think about our triangle that has a height here of 4 and a distance here of 3. Remember, this is technically -4 and -3. And our point P, whatever you want to call it, is at -3, -4. So again, we're going to use Pythagorean theorem to find our radius. R is equal to the square root of -3 squared plus -4 squared. So our radius is equal to the square root of 25, and r therefore is 5. We have our x, -3, our y, -4, and our r of 5. We can go ahead and find all of our trigonometric values. Sine is y over r, or -4 over 5. Cosine is x over r, -3 over 5. Tangent is y over x. -4 over 3 gives us +4/3. Then reciprocal. Cosecant of theta is -5/4. Secant of theta is -5/3. And cotangent of theta is 3/4. Part C, find the 6 trigonometric function values of the angle theta in standard position if the terminal side of theta is defined by y is equal to -1/2 x, where x is greater than 0. Now let's draw our line. We know that our x values for this line have to be greater than 0 or equal to 0. So we know at 0, if x is 1, our y is going to be -1/2. If x is 2, our y will be -1. If x is 4, our y will be -2, and so on. So there's our line. And that's the terminal side of our angle. The initial side of our angle here on the x-axis. So there's our angle theta. And it didn't tell us what point to use. We know that any point that is on this line is going to be on the terminal side of our angle. It's up to you what you want to use as the point. I am going to choose to use this point at 2, -1. I like those numbers. They're relatively easy to use. Obviously, the only one we can't use is 0, 0 on this line because that is the vertex for our angle. You could also use 4, -2. You could use 3, -1.5, or 1, -1/2. It's up to you. Again, we are going to need to find our x and our y. If x is 2 and y is -1, r is equal to the square root of 2 squared plus -1 squared. Therefore, r is the square root of 5. And we don't want to do anything with that. We just want to leave it as the square root of 5. So in my case, my x is 2, my y is -1, and my r is the square root of 5. To find our trig functions, sine of theta is going to be y over r. In this case, y is -1 and r is the square root of 5. But we cannot leave this as the square root of 5, 1 over the square root of 5. We need to do what they call rationalize. In order to rationalize, we multiply by the denominator. We're going to multiply by the square root of 5 over the square root of 5. And what that is going to do is it's going to get rid of the radical in the denominator, because -1 times square root of 5 is -square root of 5. And the square root of 5 times the square root of 5 is the square root of 25. Well, the square root of 25 happens to be 5. So it gets rid of that radical in the denominator. Cosine of theta is going to be x, which is 2 over r, the square root of 5. And again, we will need to rationalize. So we multiply by the square root of 5 over the square root of 5. We have to multiply the top and the bottom by the same thing because we are essentially multiplying by 1, which doesn't change our answer. It just rewrites it in another way. And we end up with 2 square root of 5 over 5. Tangent of theta is y over x. Our y is -1, our x is 2. Cosecant of theta, I'm going to reciprocal the unrationalized one, and I end up with negative square root of 5. Or we could have said r, which is the square root of 5, over y, which is -1, and square root of 5 over -1 leaves us with negative square root of 5. For secant of theta, reciprocal of this will be the square root of 5 over 2. And then the cotangent of theta leaves us with -2 over 1, or just -2. Part D, find the values of the 6 trigonometric functions for an angle of 90 degrees. An angle of 90 degrees is a quadrantal angle. We need to choose any point on our positive y-axis. Doesn't matter what point you choose. Our x value will always be 0, and our y value can be anything. Here I chose 1. So if we say r is equal to the square root of x squared plus y squared, that's 0 squared plus 1 squared. R is equal to the square root of 1, or our radius happens to be 1. Sine of theta is y over x. Y over r. Our y is 1 and our r is 1, so our sine is 1. Cosine of theta is x over r. X is 0, r is 1. Our cosine of theta is 0. Tangent of theta is y over x. Our y value is 1. Our x value is 0. We cannot divide by 0, therefore this is undefined. Cosecant of theta is the reciprocal of this, which is still 1. Secant of theta is the reciprocal of 0 over 1, which gives us 1 over 0. Therefore, secant is also undefined. And cotangent of theta is equal to the reciprocal of tangent, or 0 over 1, which is 0. Part E says to do the same thing, but for an angle of 180 degrees. An angle of 180 degrees, it will start on the positive x-axis, it'll rotate, and it'll end on the negative x-axis. And we can choose any point. We usually choose -1, but let's say we chose -2, 0. Doesn't matter what point we use. So that's our theta, and we need to find r. R is going to be equal to the square root of x squared, or -2 squared, plus y squared, which is 0 squared. R is equal to the square root of 4, so our r is 2. Sine of theta is y over r. Our y in this case is 0. our x is negative 2. 0 divided by 2 is 0. Cosine of theta is x, which is negative 2, over r, which is 2. We end up with negative 1. Tangent of theta is going to be y over x. Y is 0. X is negative 2. So therefore, it is 0. The cosecant of theta, the reciprocal, or we could say it's r, which is 2, over y, which is 0. So it is undefined. Secant of theta is going to be r of 2 and x negative 2 for negative 1 simplified, and cotangent of theta is negative 2 for x over y, which is 0. It is also undefined. F is very similar. The only thing is that now we're going through negative 3, 0. It's essentially what we did here. We just change our x from negative 2 to negative 3. So let's talk about undefined function values. If the terminal side of a quadrantal angle lies along the x-axis, then the tangent and the secant functions are undefined. That is because that is when our x value is 0. If it lies along the x-axis, then cotangent and cosecant are undefined. Up above, we saw that, and we were able to solve it. So if you don't want to memorize this, you don't have to. You can always solve it and see that it happens. Example number 2 here says, suppose the point xy is in quadrant number 3. Quadrant number 3, 1, 2, it's down here in quadrant number 3. Somewhere, we don't know where it is. We just know that there is a point on that line somewhere. And that point is going to have an x value and a y value, which are both negative. So we know that in quadrant 3, both x and y are negative. So this says for part A to decide whether x over r is positive or negative. Well, if our x is negative and our r is always positive, x over r is negative. And that comes from the fact that x is negative in quadrant 3, and r is always positive. So a negative divided by a positive equals a negative. And then for part B, determine whether y over x is positive or negative. Y over x is going to be, well, if y is negative and x is negative, negative divided by a negative is positive. And we know that because both x and y are negative in quadrant 3, and a negative divided by a negative is equal to a positive.